Okay, tonight we're going to do a probability problem, and specifically a binomial, using a binomial distribution. I'm going to do an example out of the book here. It's too much to write on my little board, so I'm just going to have to read some of it to you. The binomial distribution, for a problem to use a binomial distribution, four things have to be true. There has to be a fixed number of trials, two outcomes on each trial, like yes, no type of problems. The outcomes have to be independent, like yes, no, independent of each other, and the probability of success has to stay the same for each trial. Okay, and this is our formula, the probability of x, and it looks worse than it is. N factorial over n minus x factorial times p to the x times q to the n minus x. Once you identify what n, x, p, and q is, it really just is an arithmetic problem. So it's really not so bad. Okay, the problem reads, a survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 will have part-time jobs. So there is here. There is 5 teenagers total. So in this case, n equals 5. Now it says at least 3. So that means what? That means 3, 4, or 5 teenagers could, something about their study time or their spending money. So we need to do this actually 3 times over. I'm just going to do it once here. And I'll do it for x equals 3, but you're going to need to repeat the process for x equals 4 and x equals 5. Then add all those probabilities together. And we got n and x, p and q. What's the probability of success? They said they found 30% of teenage consumers receive their spending money from part-time jobs. So the probability of success, which is p, is equal to 0.3, 30%. And if that's the probability of success, what would the probability of failure be? It would be the difference between 0.3 and 1, so it's 0.70. Now we just need to plug all this into this and solve. P to the x equals 5 factorial over 5 minus 3 factorial, 3 factorial, 0.3 to the 3, 0.7 to the 5 minus 3. Okay, so here we have 5 factorial, that's our n, 5 minus 3 factorial, times 0.3 to the third, 0.7 to the 5 minus 3, which is 2. And let's calculate this all out. Let's do this part first. So the probability would be, let's see, 5 factorial still on the top. The bottom, 5 minus 3 factorial, that is 2 factorial, 3 factorial. And let's bring this down a little further here. 5 factorial is 5 times 4 times 3 factorial over 3 factorial, 2 factorial. Whatever number that is, that cancels out. 2 factorial is 2 times 1, which is just 2. That cancels there, so 5 times 2, that equals 10. And then we have 10 times 0.3 to the third times 0.7 squared. Multiply all that out. That's just a simple calculator problem. I'm going to cheat and look on my sheet here. 0.132. That equals 0.132. So the probability that 3 teenagers are selected is 0.132 or 13.2%. And repeat this for n equals, or x equals 4 and x equals 5 again. You get 3 different probabilities. You add them all together, and that gives you your at least 3. And that's all.